Part 3. Containers. Atoms are good for calculations and presenting strings, but more often than not we need collections of atoms. This is where containers come in handy. When we think of containers, there are two problems we fundamentally need to solve. Problem number 1, how to insert members into the container. And problem number 2, how to retrieve members from the container. Without solutions to the above problems, containers are not of much use. We can think of these tasks as operations on containers, much in the same way as we did for atoms. Another way to phrase this is that because containers contain items, atoms or other containers, their very nature requires these two operations, insertion and retrieval. For uniformity, we will refer to each item added to a container as a member of the container. Once we've solved these fundamental problems, we need to solve a third problem. Problem 3, how to work with the members of the container. We'll see some answers to this last question in our final section on constructs, but some container-only operations are essential to working with them. By the end of this section, you should be able to create a list and put and retrieve members from it, create a dictionary and put and receive members from it, know the key methods for each container, and know key operations for each container. Whetting your appetite. Example 1. Adding two matrices. Consider the problem of adding two 2x2 matrices together. Addition consists of performing element-wise addition. Our challenge is to first represent a matrix, after which we can add elements to produce the sum. The simplest way to do this is with a list. Python does not provide matrices as a type, but we can make a matrix by putting lists inside a list, just like this, which is a 2x2 matrix. This is our trick. Example 2, counting characters in a word. Consider an ordinary word like umbrella. We would like to count how many times each character occurs in it. To do this, we will use the string count method to help us. Links are provided in the instruction manual. Let's start with lists. Lists are the simplest containers in Python, and they are one of many sequence types. That is, they simply hold members as a sequence. We can create a list using the list function. Because we just created this list, we expect it to be empty. In the last example above, the len function returns the length of the list. This function works on any container and also works on strings. If you recall from the section on strings, most string operations take the form of methods because of how complex they are. The same is true for lists. Let us see the set of operations to solve the problems we presented at the beginning of part 3. Problem number 1, inserting members into a list. The append method is the most straightforward way of adding members to a list. So here's a task for you. Create a module using the standard format recommended in your first project to see how lists work and run the above sequence of instructions. What you observe is the order in which the append adds members. Problem number 2, retrieving members from a list. Once we have members in the list, we can refer to each member if we know its position. As with many other programming languages, each member's position is referred to as its index and begins at 0 up to the length minus 1. That is, if you have a list of 10 members, the indexes will range from 0 to 9. So here's a task for you. What are the indices for the members in the example list above? To retrieve a member from a list, we use the indexing operation, which uses brackets, square brackets, with an index value. Problem number 3, operations on lists. Now that we have solved the fundamental problems of working with lists, let us now turn our attention to the other operations we can perform on lists. There are only 2 such groups of operations. Operations on members only and operations on or between lists. So let's start off with operations on members only. One of the most handy and recurrent acronyms in computing is CRUD, which stands for Create, Read, Update, and Delete. It provides a handy way to outline the essential operations that are typically required to make any data storage mechanism useful. We can use the same idea on lists. We need to describe the operations by which we create new members, read, update, and delete existing members. Once we have a handle on these operations, then we can say that we have mastered lists. In the table below, we have organized the operations and methods by CRUD. The full uncategorized set of list methods are available from the official documentation. There's a link provided in your manual. Also, do not limit your experimental to the tasks provided. Try and think of ways of exploiting all of the available operations. You cannot break your computer however many errors you generate. So, creating new members. The solution to problem 1, the append method, is the simplest way to create new members. However, it is limited in that we can only create one member at a time. In many situations, we want to be able to create several members at once. The table in the instruction manual lists operators, and the table below, also displayed on your screen, lists operators and operations that do this. So here's a task for you. Create a list with any 3 numbers. Insert a 4th number into a position of your choice. Reading existing members. The table below shows you how to read existing members, which is exactly what we saw with problem 2 using the index. But you can do this for multiple members using things called slices. Here's a task for you. Create a list with any 10 numbers. Print by slicing the 4th to 8th members. Print by slicing every other number from the 4th to the 8th. Updating existing members. Now notice the use of the assignment here for this update operation. It means we are making a change to a value already present. The table below shows all of the update ways of doing an update. And here's a task for you. In the previous task, replace the 4th to the 8th members with a brand new set of numbers. Deleting members. The table below shows all the ways to delete. And it is a task for you, as in the previous task, but this time delete the 4th to the 8th members. Operations on or between lists. The table below shows how we can perform operations on or between lists. In the first one, we can check if a member is present in the list. The second one, we can check if a member is not present in the list. We can join or concatenate 2 lists using the plus operator. We can get the length, as we've seen before, using len. We can find the smallest item using the min, the largest using the max. We can get the index of the first occurrence of a value using the .index method, just index. And we can count how many times a number occurs using the count method. We can extend a list by using the extend method. And we can multiply a list. We can repeat itself multiple times using the multiply operator. We can reverse the order of our list using the reverse, which reverses the orders of the members in place. So here's a task for you. Create a list with any 10 unique numbers and print out the following: the smallest number, the largest number, the index of the smallest number, and the index of the largest number. Let's now turn our attention to dictionaries. Dictionaries are containers that allow us to store members with an arbitrary index, referred to as a key. This is a valuable property of dictionaries because of the flexibility they provide in being able to extract the exact value we're interested in, since we get to choose a key. Lists don't allow this. The index is position-based and may not be known in advance. For this reason, dictionaries are referred to as mapping types because they provide a way to contain mappings between keys and the corresponding values. we use the dict function to create a dictionary. So this is an empty dictionary, and we can get the length of the dictionary using the len function as before. So let's go back to our problems about containers and start with problem number 1, inserting members into a dictionary. To put an item into the dictionary, we simply specify our key and the value using the same index syntax. So here's a task for you. Create a new module for all your dictionary experiments using the standard structure we recommended, and print out the dictionary above. What does a dictionary look like? As you probably realized, we have almost complete flexibility on what we can choose as keys. There are some rules to keep in mind when creating keys. The simplest being that keys should remain fixed and should be incapable of change, a property referred to as immutability. Since lists can change, they should not be used as keys. That is, lists are mutable. So here's a task for you. Try to create a dictionary with a list as a key. What error does it spit out? Something to keep in mind is dictionaries are ordered by default. The order you add members is the order they will be in. This is new starting in Python 3.6. Problem 2, retrieving members from a dictionary. To retrieve a dictionary member, we must provide the key we use to store it. Since we are at liberty to choose the key, this should not present us with any problem. So here's a task for you. Retrieve all the members that were inserted into the dictionary above. What happens if we assign a new value using a key that is already present? Try it. Problem 3, operations on dictionaries. As before, we have split this into two, operations on members and operations between dictionaries. As before, we use the CRUD acronym to exhaustively categorize the operations we can perform on the members of a dictionary. Each section below provides a collection of operations and methods that are available on dictionaries. Creating new members. The table below shows the operations that you can use. So the from keys method is used to create new dictionary with the keys from an iterable and the values set to value. The set default method is used as follows. If the key is in the dictionary, it returns its value. If it is not, it will insert the key with a value of default and then return default. The default value of default is none. So here's a task for you. The dict from keys method is a handy way to quickly populate a dictionary. Create two lists of similar length with values of your choice, then call the following. MyDict is equals to dict.fromKeys list1 list2. Now print out the new dictionary and verify that it was successfully created. Reading existing members. The table below shows how we can read existing members from a dictionary. The get method can take an argument default and it returns the value for key if key is in the dictionary, else it will return default. Items. The items method returns a new view of the dictionary's members. The keys returns a new view of the dictionary's keys. Pop. If the key is in the dictionary, it removes it and returns its value, else it returns default. Pop item will remove and return a key value pair from the dictionary. And values returns a new view of the dictionary's values. In the table that's provided, the word view there, it refers to a special type which is used to, it behaves like a list but it's not a list, but we can change it into a list by casting it into a list as we've seen before. So here's a task for you. From the dictionary you created above, view the set of keys and the set of values using the methods provided in the table. Updating existing members. The set default is used to set a default value. If the key is in the dictionary, return its value. This is as we saw before. If it is not, insert a key with a value default. So here's a task for you. Test the set default method by applying it as follows. Create a dictionary and then run mydict set default with a new key with a default value and print mydict new key and then print mydict set default new key, other value, using an appropriate value for new key, default value, and other value. See what happens. Deleting members. The table below shows the operations that you can use to delete members from a dictionary. Del deletes the entry referenced by the key. Clear method removes all members from the dictionary. The copy method returns a shallow copy of the dictionary. The pop method, if the key is in the dictionary, remove it and return its value, else return the default value. Pop item is used to remove and return a key value pair from the dictionary. Operations on or between dictionaries. The table below shows your set of operations on or between dictionaries. Key in D is a way to check if the key is present in the dictionary. It will return true if D has a key, otherwise it will return false. And the opposite of this is key not in. The pipe operator is used to create a new dictionary with the merged keys and values of D and another, which there must be both dictionaries. The values of other takes priority when D and other share keys. You could use the pipe together with an equal, which is to update the dictionary D with the keys and values from other, which may be either a mapping or an iterable of key value pairs. The values of other take priority when D and other share keys. Clear is to remove all members from the dictionary. Copy returns a shallow copy of the dictionary. You could also use the update method and pass to it another dictionary, which will overwrite existing keys. And then there is the function sorted, which will sort by keys, and reversed, which will returns a reverse iterator, which is you'll be able to see the reverse order of the insertion. So here's a task for you. Try out the following methods on your dictionary: sorted, reversed, and clear. So here are the key takeaways from part 3. Containers are essential when working with collections of members. Whether they are all similar or different, we've covered the fundamental containers, each of which have distinct features. Use lists when working with sequences of similar types or when you need to predictably work with multiple members using indexes. Use dictionaries when you need to predictably store and retrieve members. So go back to the instruction manual, and there are a few other resources. You could check your progress, a set of multiple choice questions, and there are some challenges. There are 3 challenges there which will extend the problem of adding matrices. And if you want to, you could try your hand at multiplying 2 matrices. And challenge number 3 would be counting words in a long string. So these are exciting challenges that you can try out using all that you have learned in this section.